We live? Okay, thanks, Marina, again. So I have, so some of you know last night when I was going back from the party to the hotel, the god ate my homework, or the dog ate my homework. So I have demos, but I leave the demos to the end so we can control time better. For that reason, Dominik, who practices talk multiple times, will go first.
Okay, hello everyone, and thank you for joining our session on an update on Chrome Typography and FontTools. As Marina introduced us, thank you. I'm Dominik. I work on fonts and text in Chrome, and as part of the Chrome layout team. And I'm here to give you an update on what has been happening in terms of typographic tools that are available in Chrome since TYPO Labs last year. Today, I want to mainly talk about three things. I cannot avoid talking about variable fonts and what has been happening in Chrome since last year. I want to talk about color font support that we're bringing to Chrome, CFF2 support, and I want to do a bit of an excursion into text decoration styling, because underlines are important on the web. So here, it's Behdad and me last year at TYPO Labs presenting variable fonts in a pre-release version, the canary version, as we call it, of Chrome. And there were certain restrictions. It was canary only, so it was only in a pre-release. It was not widely available to all of our users. It would only be for someone with a special interest in trying the feature out. The variations feature was only active behind a flag, so you would have to activate this flag to test variations. And the integration was restricted to low-level integration, doing it with font variation settings. Then Chrome version 62 came out in October 2017, so that was pretty much exactly half a year after TYPO Labs. So the variations reached the stable version, became available to all of our users, and was supported from the beginning on all Chrome platforms. And also, with this release, Chrome 62, font stretch, style, and weight matching became available. So I have a quick demo of the Kairos font designed by Terence Vines here. And wait, where's my cursor? Yeah, so here's the Kairos font matched in 75% width, and in 100% width, and in 125% width, and in various weights, and not only discrete weights that you know from the previous CSS specification, only like at increments of 100, but also at like fractional increments. And if you look at Web Inspector here for this, then it's a little bit small, but you can see that these are only styled with stretch and weight. Okay, let's go back. Yes, but the restriction applies that Peter mentioned earlier, that this applies to web fonts. So our implementation supports variable fonts when they're downloaded from a URL and when they're declared with the CSS font face. And one of the next steps is to change that and support variable fonts on those platforms that have native support for them, such as macOS and Windows 10. Also, we're working on supporting optical sizing. If you want to stay close to the bleeding edge and learn the first when this feature becomes available, I recommend following this Chrome bug. So you can start this bug. We have this sort of feature in the bug tracker to get informed about updates, and then you'll know it first when optical sizing becomes available. Last year at TYPO Labs, I was talking about the hybrid architecture that we're using to support variable fonts on operating systems that don't have native support for them, such as older versions of Windows. What you see here is a table of what font rasterizer for existing static fonts we're using, and what font rasterizer we're using for variable fonts. And Chrome OS, Linux, and Android is pretty much the same. It's the open source stack that we know well and that we work on in our products. On Windows, you see direct write and free type for variable fonts. And on macOS, we're using core text on latest versions, but we're using free type there as well on versions older than and down from 10.11. And last year at TYPO Labs, I mentioned that this hybrid architecture allows us to do a couple of other tricks, and it's very useful for us to have free type on all Chrome platforms so that we can do things such as color fonts. And it's getting a bit technical now, but that's why it's TYPO Labs. This is a bit of a quick recap of what color font formats are available. On the left, or from the left to the right, you see CBDT CBLC, which is a bitmap format initially proposed by Google and modeled after the EBDT, EBLC monochrome bitmap fonts. What you store in such a font is a restricted, or it's a subset of PNG, and one of the examples of such a font is Noto Color Emoji, which is used on Android and in other Google products. Aspix is Apple's bitmap format. You can embed multiple image formats like JPEG, PNG, and TIFF in it, and the sort of prototype or the most prominent example of it is Apple Color Emoji. Color CPAL is a format initially proposed by Microsoft, and it works pretty much like a layered TrueType outlines that are assigned a color from a color palette. And Sego UI Emoji is the most well-known example of such a font. Then we have SVG graphics, SVG OpenType fonts, which contains a subset of SVG inside the SVG glyph table. And Gilbert and Emoji 1 SVG are some examples of SVG fonts. So when I said we have free type in Chrome in the hybrid architecture, it means that we can now bring CBDT, CBLC, and Aspix to all Chrome platforms. So we're using free types rasterizing and bitmap scaling features for supporting these two bitmap formats on all platforms. And shout out to Roel, who provided the Chroma Check test site. And you see here Chrome on Linux displaying support for Apple Aspix and CBDT, CBLC. And since we're in Berlin, I thought I can also demonstrate this with the bear emoji. From the back to the front, you see Chrome on Mac, Chrome on Windows, Chrome on Linux, and Chrome on Android, displaying all the same website, which uses Noto Color Emoji as a web font, and so CBDT, CBLC displayed on all of these platforms. So this is a useful feature for someone who develops a website and wants to use the same emoji font or the same color font across all platforms that Chrome supports. Yes, so this is what I mentioned. For displaying these, we now use the same hybrid architecture that we use for variable fonts and send color fonts through free type on platforms where we don't have native support. Aspix on Mac, we do render through core text. CBDT, CBLC on Mac, we do send through free type. As a next step, we're looking to explore color CPAL support as well. Actually, Behdad and I are meeting next week to discuss what we can do about that. I can't promise anything yet, but it's something we'll look into. Another advantage that this hybrid architecture brings is support for CFF2. FreeType's CFF2 or CFF rasterizer was completely renewed, and we're making use of that feature in Chrome as well. So we're supporting CFF2 on all platforms as well. And I have a quick demo for that too. Last year I was showing a similar thing. Here's the Adobe variable font CFF2 version this time. And last year I was only able to show this with the TrueType outlines, but now here the variable font also works with CFF2 outlines. Yeah, you can believe me that this demo is downloading the CFF2 version. Okay, then I'd like to, after these font format supports and talking about variations, I'd like to come to a different aspect of typography on the web, or typographic styling on the web: underlines and CSS text decorations. This is the classic set of text decorations that you have. Text decoration line, you can choose where the line should be placed: underline, overline, or line through. Text decoration styles, like solid lines, double, dotted, dashed, wavy lines, and text decoration color for selecting a different color. I think there's interest in text decoration styling on the web. For example, I was looking at the LibreFonts website yesterday, and it actually has some interesting wavy underlines, which are not done like this, I think, but we'll try to provide more richness in what underlines can look like. And there's perhaps one thing missing that used to be available in browsers. So here's a screenshot of Netscape. And Ibrahim, who is also a contributor to Chrome, pointed out that we lost ink skipping somewhere on the way. So here you see, if you look at the descenders of the P, the underline is skipped, and in the word messenger, you see that the underline is skipped. And if you watch this YouTube documentary about the release of Netscape as a Mozilla open source project, you can see screenshots of Netscape rendering underlines like this. And Ibrahim is asking the right question: does anyone remember when text renderers lost this ability and how we didn't notice? And we'd like to bring this back to Chrome. So we do ink skipping underlines. Here are some text examples of Latin, Burmese, and Arabic. And this is the new default that we're using. And we believe it does improve readability, and also because Safari has been shipping this since, I think, Safari 8 in 2014, we'll also improve interoperability between browsers. And I've pointed out some articles where the web design community has certain, shows some support for this being an improvement. So we're setting this as a new default, but of course, if that does not make sense, this ink skipping feature does not make sense in your context. For example, we've seen it doesn't make so much sense for displaying code, for example, then you can disable it. So one CSS text decoration that wasn't on the previous slide, but that we have now added, is ink skipping and gaps for descenders through the text decoration skip ink text decoration skip ink property with values auto and none, and auto being the default. During TYPO Labs, we talked about the standardization process and how it's important for aligning interoperability between browsers. So my colleague Koji Ishii helped me to discuss this in the CSS working group, so that we came to the resolution from renaming the old property text decoration skip to text decoration skip ink with values auto and none. In Chrome 57, we shipped this as a feature to opt in, using text decoration skip ink, which was the previous version of this property. Now that browsers are more aligned on this, we're shipping this in Chrome 64 with the renamed property text decoration skip ink, and setting the default to auto, so it's default on. And let me talk a little bit about the implementation. What you see here is a lowercase j. You see the baseline, the underline offset, and the underline thickness. And if you consider the underline being actually two lines, the upper boundary and the lower boundary in the coordinate space of rasterizing a line, then what we're doing is we're computing this line text intersection area and forming the maximum of this. So we are doing separate passes for doing a path intersection for the upper boundary and the lower boundary a boundary and taking the maximum of that. And then we're using the thickness of the underline to sort of to offset the continuation of the underline. And so what you see here is that if the underline is thicker, then the gap is larger. If the underline is more subtle, then the gap is narrower. So to give you more control over what you can do with the underline, the CSS working group has now proposed 2 additional properties for underline styling. Text underline offset with the default value of auto, which is do what browsers are doing at the moment. Then just 2 days ago or 3 days ago, an additional keyword from font was introduced to actually use the metrics from text, from the font. And this leads me to the same appeal. Please set the underline metrics in your fonts so that the underline can look good with your font, and spend some time on what could be the correct thickness for your underline and the correct offset. I think these properties are important. We see a lot of hacking around styling underlines, for example, using CSS borders or using other tricks with sort of underlay images and things like that. So I think having a bit more native support in the browsers is useful and can improve performance compared to other hacky solutions. Yes, so there was the auto value here, which did something magical to come to a conclusion about what the underline should be. And we've tried to move to a situation where we use the metrics from the fonts, but we had to roll back on this feature because often fonts don't set this correctly. They're too thick, there's some random default, or there's 0 or some broken value. So this is just a quick reminder, please set your underline metrics, and I think when the slides become available, you can use this. In the post table, these are the values underline position and underline thickness. And for variable fonts, you set them in the UNDS and UNDO tagged values in the MVAR OpenType table. Yes, wrapping up, I've shown you today that variable fonts are shipping since Chrome 62, including stretch style weight matching for web fonts. Cross-platform color fonts are available in the Chrome 66 beta right now. Ink-skipped underlines shipping since Chrome 64 by default. And on the agenda for us to work on are variable system fonts, optical sizing, and additional tools for underline styling. And with that, I would hand it over to Behdad for speaking on FontTools. Thanks. Okay.
Cable man.
This one.
No, I need the.
Yeah, there is not. Yeah.
Oh, that might work. Thanks. Yeah, that works better.
I'll sit down.
That's fine. Mm-hmm. Okay. No, I do have slides. Okay. So the first time I presented on FontTools was in September 2014 in Barcelona, A-Type. And back then, that's when I had picked up maintaining it, and it was unmaintained, and I couldn't get hold of Yus to talk to him. Anyway, this is slides from those days. Ugly, I know. And this is what I presented here last year. And let's continue. So I'm going to talk about what I've been doing or what we've been doing since last year. And well, what is FontTools? It's a library for dealing with fonts, and font engineers use it every day. Use FontTools started in 99-ish. I picked up maintaining it in 2013, added subsetter and other modules and tables and bug fixes, and then passed it on to Cosimo to maintain last year. It has since grown into an active community of contributors, which I also will touch on. So since last year, this is what I showed last year. Last year, everything was about variations. So I had done GPOS merging and this interpolatable module that I talked about extensively last year. At the time, what was still remaining, we didn't generate AVAR or MVAR or stat table or feature variations or CFF2. Now, since then, we have done some of those. GPOS merging has been further improved, and I can report that I haven't got any bug on it for the past 6 months, so that's stable. We generate AVAR tables from the design space automatically. You don't need to worry about it. MVAR, the same thing. MVAR includes the variations of font metrics like underline position and other metrics. Again, you don't need to do anything. You just set them in your masters, and the pipeline takes care of generating that. Stat table is Microsoft's favorite variation table, even though it's not variation specific. We do now generate a simple stat table from the design space document. It only includes the axis names and coordinates. It doesn't include any extra information. CFF2 generation didn't make much progress. We did integrate Reed Roberts' code for CFF2 in FontTools itself. However, it's not integrated in our variation font generation, so you still have to use the make OTF pipeline for that, which calls into FontTools, but is not the same as FontMake. Feature variations I didn't get to touch on. So on the GPOS merging, as I said, we now do all kinds of different things. So you don't need to worry about it as long as the GPOS tables of the different master binaries are similar enough. The code should take care of it. So this is the AVAR generation that I was talking about. The AVAR is a mechanism to allow for nonlinear axis control. So for example, if you have a thin master and a black master, you all know that the weight progression is not linear. And there are multiple people who have curves named after them. You can implement those in the AVAR table. The way you do it in your design space document, you just add extra mapping points, and then these represent a piecewise linear function approximating your desired curve. And this is automatically converted to the AVAR table by the pipeline. Feature variations, again, that's also known as a bracket trick, brace trick, other tricks in Glyphs land. We still don't do that, even though I heard that Yoast implemented this for Microsoft. He didn't contribute the code back. CFF2 generation, as I said, we've cleaned up the CFF code, but it's not implemented in the rest of the FontTools library. So this is all the contributors to FontTools since last year. There's a good 27 of them contributing about 1,100 commits. Because of that, I think I put a slide to say that I moved the FontTools from my personal GitHub account to a FontTools organization account, but I checked with Cosimo. He thought we did this since last year, but now that I think about it, we did it 2 years ago. So that's how good my memory is. Anyway, so that was the update from last year. We've done a bunch of other things. So I'm going to talk about new features, new font table implemented, new libraries in FontTools itself, new optimizations mainly to the variation workflow, but also CFF. And then last and definitely not least, a new variation model, which will invalidate all your variable fonts. In terms of new features, one of the most wanted has been handling true type collections. I wish I had sample code to show you here, but yeah, the dog took my laptop. But basically, instead of TT font, now we also have a TT collection class. You pass in the TTC file, and it loads all of the individual font faces, returns a list of TT fonts, returns an object that has a list of TT fonts inside, and you access them and modify them. When you save them, it does the right thing and does table sharing and everything, so you don't need to think about that. It's also trivial to create a new TrueType collection from multiple faces. You just open the TT fonts, create a TT collection, put them inside, and save it. Anything funny there? Flash? Yeah. Valid mutator is the module that instantiates a variable font, a static instance of a variable font. And last year it wasn't complete, now it is. In part thanks to Jens, MBAR is applied, the IUP true type optimization is applied, so it has been complete, and I think Google Fonts is using that to instantiate variable fonts. We've had bugs coming in, but in general it should be usable. Subsetting variable fonts now works correctly. Well, it was correct before, just not optimal. Basically, there's this thing called the item variation store, which is a storage area that all the deltas and variations of kerning and other GPOS operations are stored in. And before, if you subset the variable font, we were not pruning, removing the unused items from this item variation store, but now we do that correctly. So subsetting variable fonts should be complete. If it's not, just file a bug. Philip got some additions for character variants and miscellaneous syntax, thanks to Miguel and Adobe. New table, Sasha implemented the Murks table, the Apple shaping table that uses state machines. And in other news, I implemented that in Harfbot. It's not hooked up, but next year, by now, for sure, you can use A80 fonts with Harfbot natively in Chrome and Firefox, and eventually Android. Martin Hoskin contributed the graphite tables. Graphite is another shaping scheme. There are a bunch of new libraries under the FontTools module. Simple one is svglib. It's very simple. It's just a little piece of code to help you convert outlines from an SVG to a glyph font pen. The pen protocol, I think. SVG pen also. Is that correct, Cosimo? Is that all it does? Yeah. OK. Oh, the SVG pen goes the other way around. You can draw a glyph to an SVG. So basically, SVG to a glyph shape and glyph shape to an SVG. The design space lib is library from Eric van Blokland that reads and writes design space files. And thanks to Johnny, we imported it into FontTools, so there's one fewer library to worry about. I started using it. There's a few things, rough edges that I need to figure out and fix. For example, it doesn't support the axis mapping right now very well, but in general, that's going to make it easier to read and write design space files. And I show that. I have a demo of that one. The future, what we are thinking about, UFO lib, definitely we want to fold it into FontTools. UFO is such a central part of font engineering now, and it makes a lot of sense to have a very good implementation in FontTools itself. Adrian Tatar has been experimenting with rewriting it from scratch using better engineering practices. And there's a branch that is very promising. It's much faster than the one we have right now. So that will be part of the speeding up FontMake pipeline, which that's only one of the places that the pipeline needs some help. Kernel is, we are discussing about it. I still don't have an algorithm to implement it, but it will be essentially just an optimizing kern, a kern table optimizer. It's not about auto-kerning or anything. Color lib will involve converting between the different color font formats. So we want to provide that just as a simple tool so all the foundries don't have to think about it when serving color fonts. Optimization work I did, this is the part I enjoy most. The IUP-like optimization in the GVAR table, now we implemented it by default, it's enabled. Even though I think Adobe implementation in Photoshop didn't support it initially, but I believe that has been fixed. So if you rebuild your fonts with FontMake, you are already getting the benefit of the IUP optimization, makes the glyph table a few percentages smaller. Or depending on what you do, if you have a spacing axis, you are just moving the entire outline around, then the IUP optimization saves a lot. The variation store, as I said, variation store is where the deltas for kerning and other values are stored. And before, the first time I designed this data structure and designed it to be very efficient and storing values and optimize them to the minimum bytes needed. When I implemented in FontTools initially, I didn't implement any optimizations. So for example, for a Noto Sans Arabic font that I was testing with, the GDEF table had a 1 megabyte variation store, storing all the kerning and positioning deltas. When I implemented a full optimizer, that went down to just under 60 kilobytes. So rebuild your variation fonts. CFF Leap got a couple of optimizers. It's an operator specializer, if you know the char string lingo, and also the width optimizer. Both of these are just byte level optimization in CFF. There's no Adobe people around. I don't know why someone would use CFF, but you get better ones now. Why? Okay, this is the tricky part. So if you were there last year, I think, Eric did an entire talk about this issue of variation model, my code versus mutator math, his code. And so this is a vague problem we are talking about. Given a few masters, so a master is a point in the design space. So you are given a data point for a point in the design space, and a few of them, what you are doing, you are building a surface that describes the expected thing, font, point, position, color, whatever, in the entirety of the space. So you are creating a manifold out of a few points. And there's no unique way to do this. And figuring out the shape of this manifold is what the variation model does. And there were problems with how we handled this, especially with unusual design space master configurations. And I have since found better models, so that's what has been implemented. So again, someone asked Georg the other day this question. Yes, the variation model has changed. If you rebuild your fonts will behave differently, but I'm fairly confident first, it's for the better. Second, most of you probably didn't have unusual configurations. We did. In Noto fonts, we had only one, like Noto Sans Thai, which is a 7 master font, and I showed that one. But to debug this problem and fully understand what's going on, this has been discussed, being under discussion on GitHub between Georg and Eric and Cosimo and Adam and Marek and others for a year. This was about differences in interpolation between glyphs and FontMake, and then finally I had Cosimo explain it to me, and then I wanted to visualize it, and I hate making visualization, it's so hard. So I added this new module called value plot, but while doing that, I needed to read the design space, so I figured that that's a good excuse to use the new FontTools.design space lib, but I hit bugs there, tried to fix bugs there. I noticed that there's no maintainer for design space lib, so I started finding a maintainer, and anyway, this video basically summarizes how my life goes, for those of you who have seen it. Okay, with that, I'm going to try a live demo and try to start building it one by one, so hopefully you can follow. I can. Okay, so there's two modules here that help me a lot. One is the value model, and the other is the value plot. And both of them, I added a simple interface where I can enter master positions here, and then it tells me what the model thinks of it and how it resolves it. And let's start. This is all the numbers I'm going to show are in a normalized space, which means your base master is always at 0. And I'm going to use a two-axis configuration because that's the minimum you need to show this problem. So something like this is so like you have one master only, nothing. There is no variation. And if I plot this, this is how it looks. Basically, what it's saying is this is the location of the master at 0 and 0. And what this function is saying, it says everywhere in the variation space you have the same master. This master is completely used across the space, which is not very interesting. Now let's add something like a bold master at 1 and 0. So the first axis is the weight axis, let's say. Now this one is more interesting because it still thinks that the regular master is covered everywhere, which makes sense because that's the model that variable fonts work. You have the base master everywhere, and then you apply deltas on top of it. And then this is the delta for the bold master. So the bold master is located here, also here. So this is what we call the support function for the deltas from this master. What this is saying is, it says when you increase weight from 0 towards 1, we get increasingly more of the bold added up. So by the time you get to the end, you have the bold master. So far, so good. Now, if we add let's say we have a semi-bold and a bold. So again, the regular master covers the entire surface. The semi-bold, the support for the semi-bold starts from the regular. It peaks at weight equal half, and it then goes down back to 0 when we get to the bold master. And then the bold master support starts from the semi-bold at half and goes up to 1. Right? So far, so simple. Well, I see Sampo agreeing, so. Now let's add a width master, 0 and 1, expand that. Okay, so this is the regular, this is the semi-bold, and this is the bold, and you see that the condensed or expanded, it works in the other dimension, and from 0 to 1, it goes up, and it doesn't care about the weight axis. It's the same across the weight axis, right? Now, what becomes more interesting is when I add a bold expanded master. So the last one is the bold expanded master. It's the corner of the design space. Now what to observe here, and this is the key that Eric wanted, is the support for this master starts from 0 and 0 and goes all the way up to 1. What was the previous model? Let me see if I can reverse things quickly. What's going on? Okay, so this is the new model, and this was the old model. New, old. So the old one, the support for the bold condense would only kick in from semi-bold up to bold. And that was not desired, so I have addressed that. If you add a semi-bold expander, then things are different. But in the absence of a semi-bold expander, if you only have a bold expander, you want the support of that master or the effect of that to start kicking in as you increase weight from 0 up to 1, not only from half of the space. So that's what I've addressed. And if we look at what Eric showed last year, he had the same thing, just in more colorful ways. I don't remember how to interpret this. But believe me, it's better. OK. And these plots are kind of cool. You can move them around, but they're super slow. And that's, I believe, all I had to show. And time-wise, we are doing good. So let's go to questions. Thanks. Thank you.